Hello, welcome. My name is Ricardo de Matos. Welcome to Mission Critical Stream Processing with Amazon Kinesis and EMR. I'm a solutions architect out of our Boston office, and I'm going to be presenting today with DataZoo, who will be joining me on stage momentarily. This is a 200-level session, so we're going to skip through some of the intro things really quickly and get right into some of the questions that mitigations that we'll talk about mission critical processing. So this is our big data services portfolio, and customers use this to manage, collect, store, and analyze mission critical data. Right? So mission critical data makes its way into AWS through either Direct Connect, import and export, and now through Kinesis. And we store that data using Amazon S3, DynamoDB, and process that through EMR, Redshift, or through custom databases and applications through EC2. And customers are doing the analytical processing that really are driving big business drivers today. So we're looking at customers that are processing billing information, login information, click-through information, and they're doing so in a batch mode, but there's really a big driver now to do things more on real time. So there's a big need to look at this mission-critical information and make decisions in real time. But the fact that it's mission-critical still has not changed. So we're going to make some start asking some questions here around some typical data flows that involve Kinesis. So the big focus today is going to be Kinesis and EMR. And as you already know, Kinesis is our ingest service, and you can push data into it through some various methods, HTTP posts, using our SDKs, using plugins that we open source, and even writing your own plugins. So we're going to talk a lot about pushing data, producing data into Kinesis, and also reading it out of Kinesis. And what we find is the customers typically have a data flow that kind of looks like this. You have a client or sensors if you're using, if you're pushing data from my internet devices, and those devices or servers are pushing data into an aggregator, which in this case we'll be using Kinesis as an example. That information is being continuously processed, and it's being stored for other downstream or batch processing in durable services that are tapped into by other analytical services. So the whole purpose of today's session is to ask some tough questions. So what could possibly go wrong, basically, in any of these points here? So we're going to be looking at potential issues, failure modes, I'm going to call them, when the client, for example, is not able to reach the ingest point, when the client is not able to keep up with the massive amount of events that might be coming through there. And we'll have some good numbers to talk to you guys about. We also look at failure modes that could happen at the service that is aggregating all this data. What happens when the service, with the record, while it's being aggregated? How durable is that record? Is that aggregator going to have enough capacity? We'll take a look at approaches that we've taken to mitigate for those failure modes. Continuous processing is also very interesting, right? We'll talk in detail about the KCL for the Kinesis Client Library, but looking into some specific edge cases on how do we deal with bad records? How do we deal with the resilience of where the KCL is running, the worker fleet? And of course, storage. If you are familiar with Kinesis, the records are in Kinesis for 24 hours. The time to live for the record is 24 hours. That's what the service was designed for. And we're going to look at the edge cases of what happens, what type of mitigations need to be put in place when you go beyond that 24-hour window, right? And of course, in analytics and reporting. Now, this is where I'll step back on stage and talk specifically about issues that you could have that have to do with record order, and also the ability to be able to replay the records that were archived to go beyond that 24-hour window. So this is what you're in store for, but we're going to give you guys some context. So I'm going to invite to stage Akesa from DataZoo, big customer in Boston, and he's going to be talking about his mitigations that he put in place for these cases.
Thank you, Ricardo.
Yeah, okay.
Thank you, Ricardo. Thank you, Amazon, for giving us the DataZoo an opportunity to share our experiences here. Ladies and gentlemen, good afternoon. Thanks for being here. We appreciate the time. Hope you learned something useful. My name is Akesa. Kosuru. I'm the VP of Engineering at DataZoo. And DataZoo is in digital ad serving business, and where every ad inventory is bought and sold via programmatic auctions. So we have a need to continuously process the data to tune and fine-tune our allocations and bidding strategies. And we've been using batch systems for a long time. Batch systems are great, but they're slow. So Kinesis fills in an important gap between transactional systems and batch systems. And it opens up doors for continuous data processing. What is continuous data? Data that has no end. It keeps on flowing. And the other good thing about Kinesis is it's language neutral or framework neutral processing. It is, you can do it in MapReduce, you can do it in SQL, or any other language that it supports bindings for. So the motivation for us is the ambition to learn quickly and apply those learnings in real time. So who is DataZoo? What do we do? How do we fit in? DataZoo, we are building a marketing cloud on top of Amazon. And we have the scale and automation to harness the big data to find marketing opportunities, and with one goal. That the goal is to, how do we make marketing organization more effective in making their daily decisions? And we operate at a large scale. Just last week, we processed, we hit 1.2 million ad requests a second. We make billions of ad decisions a day. We process petabytes of data. We have globally about 3,000 servers deployed, and we collect about 15 terabytes of log data that we are pumping in through the Amazon cloud. We are listed as one of the fastest growing companies in Inc. 5000. We were born out of MIT labs. And so how do we fit in? So where do we fit in? And what we do is today's digital lifestyle produces torrents of consumer data. Anonymous, but still very valuable, where the users leave their intent and taste that we sieve through, looking for perfect opportunities to connect and engage with the consumer along their buying journey. And via programmatic marketing APIs, we expose those opportunities and connect the advertisers or the brands directly with the customers. And we do that in a new way, being real-time, being ambient, and being sentient. Simply put, programmatic. So real-time meets mission-critical. Let me state the obvious. Mission-critical is anything that's important for a business mission. This is the data that we can't afford to lose. So we take a lot of precautions to bring it into the systems. Why is it so important? Before I talk about the guaranteed delivery, let me talk about why this data is so important. When we serve an ad, we get a confirmation. This is all through APIs, and machines are exchanging data. We get a confirmation back. And that confirmation has a winning price in it. And that's what we use for our billing information. So if we lose the data, we lose the revenue. That's how we get paid. So this is very important data for us. So having said that, we have to define, we wanted to bring in this mission-critical data through high speed. We process about 1.2 million requests a second. So we need to figure out a system that can bring in this kind of volume of data. So let me put down some requirements, non-functional requirements. The non-functional requirements are availability, right? Because these systems are highly available. We can't go down. And if our ad servers are pumping that fast, that volume, the backend has to catch up with it. So the throughput has to catch up with it. We operate in a low latency environment. Typically, the ads are served, we are bidding on the auctions in milliseconds. So this system, whatever system we end up using, has to fit into this low latency environment. And durability, no record loss. We can't afford to lose this data. I told you, this is how we get paid. So it's extremely important that we establish these non-functional requirements. And then the other thing, too, is we would like to have framework-neutral processing, whether it is MapReduce or SQL or whatever it is. The idea is to ingest the data, read the data, and do something useful with it. So with that said, let's look at some of these production logs. These are the two samples that I took out of the production logs. On the left-hand side, you see a confirmation record. So the confirmation record has this price micro CPM. That's our winning price. This is how we actually bill our customers. So we need to keep this data around. And also, let me call your attention to UUID. I'm going to talk about this in a later slide. So we tag those events with a unique ID that then gets tagged and sent through the system. On the right-hand side, there is a fraud record. Because there's machines exchanging information at high speed, there is room for fraudsters to sneak in. So in an anti-fraud effort, we are building a fraud program where it detects the users. We attach a third-party pixel, and if we detect that this is a fraud user, we stop him right at the gates. This user doesn't even come in. So that's an example of a fraud record. Now let me talk about a typical ad serving flow. This is not an architecture diagram, folks. This is just the data flow diagram. This is a specialized version of what Ricardo talked about earlier in terms of the general purpose data flows. On the front and center, you have this real-time bidding engine. This is the system that's actually facing the internet, the exchanges, and the user, the browsers, and so on, bidding on the auctions. It is serving at light speed to the consumers. And all this, it's basically hundreds of servers, Linux servers, and we have a Flume agent locally deployed on every box. And the RTB engine, whenever it bids on an ad, it logs that information to the local Flume agent. The local Flume agent then packs multiple log lines into a single one and then sends it over to Kinesis. And if we win the ad, we also have CDN calls and retargeting things that are going on. The meta point of this is all the real-time flows are wired in through Kinesis. And then we have an archive application on the other side. Archive application simply copies the data that's in Kinesis, puts it in S3. And I'll tell you why we chose to do that. And we have a golden rule at DataZoo, which is all data in and out goes through S3. And once the data made it into S3, we have that other reporting. It's labeled as reporting. That's the machine learning cluster, taking the data out of S3, processing it. And for those of you who are data scientists in the room, it produces models or classifiers that then get fed back into the real-time bidding engine. And there's a continuous loop. And we do this continuously throughout the day. And then we use a Qubole for ad hoc analysis. So I talked about guaranteed delivery. What does it mean? How do you know that you are not losing data? Let's dive in. The first thing you need to do is to monitor your data flows. I'm not talking about system monitoring. I'm talking about end-to-end data flows monitoring. The first thing you need to do is to have enough tracing and monitoring in place. On the right-hand side, you're looking at a snapshot of a dashboard. It's got a whole bunch of real-time counters. We're going to actually show you a live demo how that works. And out of the box, CloudWatch and Kinesis gives you a whole bunch of metrics that are very useful. Things like put-get ratios, iterate range, and so on. So they are built-in counters. You can use them readily. On top of that, we've augmented our own metrics. For example, throughput exceeded exceptions. Why? Because you are seeing those exceptions on the client side. See, Kinesis can actually track anything within the bounds of Kinesis. But outside, you have to track it yourself. So our clients, we've extended them to monitor the throughput exceeded exceptions. We need to know if we are running out of the shard capacity that we have provisioned. I'm going to come back to that one in more detail. Keep an eye on the producer and the consumer drift. The reason why this is important is producer is producing the data as fast as you can, and the consumer is consuming the data. And if there's a drift, you need to know, and you need to react. You need to figure out. So these real-time dashboard counters will help you diagnose those things. But real-time dashboard is just like a dashboard in your car. When the light is on, you have to open the hood and look at it. What you need is the logging, a detailed logging at the event level. This is where UUID comes in handy. If there is a suspicion that you have a data loss, where do you look? Real-time counter is going to show producer had produced 59, and consumer has consumed 49. Where did the 10 go? Who knows? So what you need to integrate deep into the logging infrastructure. So you can do several ways of doing. We have these CloudWatch logs. We log every single UUID. So on the producer logs every single UUID that's sending through Kinesis. Consumer reads the UUIDs, and when we have a suspicion, we play the logs side by side. We see which one is missing. Well, that'll at least tell you what's missing, but it won't tell you where the leakage was. If you really want to go into the details of that, then you would need to look into some kind of a distributed tracing. Google published a paper called Dapper. It's a very interesting read. You might want to take a look at that. And Twitter also has an open source implementation. That allows you to trace your distributed systems front to back. And that's the kind of level of detail that you would need to diagnose distributed system issues. On the left-hand side, you are looking at a chart. This is one stream that was scaling up. When we scale up, we actually take it in ramp up slowly. That chart was a live CloudWatch chart for a snapshot of about 24-hour period. And as we were ramping up the number of shards, we were ramping up the clients. So that's the number of messages or bytes written to Kinesis shards. And on the right-hand side top is 1 gigabyte per second throughput into the system, i.e., million messages a second. Folks, that's just one stream. And the relatively flat line in the middle is when one of our developers, Steve Zesk here, fell asleep in front of the computer when we were ramping up. So CloudWatch has a lot of built-in metrics ready to go, and use it where it makes sense. And then now let's talk about, so having captured your monitoring and tracing, now you want to look at the failure modes. Let's talk about the failure modes. Like Ricardo already introduced, there's failure modes you need to think about on the client side, Aggregator, which is in the middle, which is the Kinesis itself, and on the processing side. So let's start with the client. There's two important things that you can think about. What can go wrong? The client is not able to reach the Kinesis stream, the endpoint. Well, there could be many reasons. Let me just cite a few. The first one might be that your client is having a DNS issue. It receives unknown host exception. Or the network connectivity is lost between you and where the Kinesis endpoint is. Or a third one might be, very simply, you haven't provisioned enough shards on the Kinesis side. Kinesis comes in the units of shards, and your unit of scalability is shard. And we'll talk about that in the upcoming slides. And then let's say it is down or it's not reachable for whatever reason, then the client that you have, can it survive the accumulation of the events on its side? For example, we are serving 1 million requests a second. If we were to accumulate all that on the Java side, we're going to run into out of memory very quickly. So you got to think about and address these failure modes ahead of time. With that said, let me invite Steve to show us a quick demo. So the idea behind this demo is, if in case you are running an exception on the client side, like a throughput exceeded exception, what do? I talked about that one of the possibilities is that you haven't provisioned enough shards on the server side, which can happen because if your clients are scale up and down rapidly, and you don't have enough capacity on the Kinesis side, you might run into throughput exceeded exceptions. So with that said, right now, let me pass it over to Steve, and he will explain what's going on this chart. Steve?
So this is a dashboard we put together that receives metrics from both Kinesis producers and consumers. The first graph in the first row shows the number of shards we currently have in our stream, which is 10. The second graph shows the number of throughput exceeded exceptions we're getting for writes into Kinesis. And this is around 80 to about 150. So for the sake of the demo, we've intentionally come in sending more data than the stream can handle. So the first graph in the second row shows the number of puts per second we're doing, which looks like it's 150 to about 200 per second. The second graph is the number of 1 kilobytes of events per second we're sending to Kinesis. So in order to improve throughput, we pack as many events into a single put as possible, which is why the number of events is about 50 times the number of puts. And this final row is the two consumer applications we have sending data to Kinesis, two consumer applications receiving data from Kinesis, and they're what we call archivers. They read from Kinesis and write to S3. They're both running on top of the KCL, and you can see that they're both getting about an even distribution of the data. So for the first demo, we're going to focus only on this first row. So again, we're sending more data than our stream can currently handle. So what we're going to do is we're going to double the number of shards in our stream to 20, and then you'll see that the number of throughput exceptions will come down to about 0. So we discovered it takes about 30 seconds after you split one shard before you can split another shard because the stream goes into an updating state. So I'm going to hand it back off to you, Keza, and then a little later we'll come back and we'll see where our exceptions are at now.
Thank you, Steve. So the idea behind that demo, by the way, this is live, guys. This is not a PowerPoint. This is actually a real live demo. It's not. Can you see if it's hit the play button? All right, thank you. So we've seen some of these issues happening. So purposefully, to demonstrate in a controlled environment, we've created the Kinesis stream with the fewer shards, and we're bombarding it with the clients. And so we were seeing these exceptions. And what he's going to do in the meantime is going to do some magic, scaling the shards in the back end. So let's come back and see what happens to the throughput exceptions when we come back. In the meantime, so how do we mitigate some of these client-side issues? Well, before you get started, assess yourself what kind of a tolerance you have for data loss. Sometimes if it is a research kind of data, you might not have to go all the way. But if it is mission-critical data, then you do want to go all the way. So here are some tips. Amazon supports, SDK supports back-off and retry policies. This comes standard with the SDK. You can provide your own implementation. Back-off is how long in milliseconds to back off between retries, and retry is how many times you want to retry when you are having exceptions reaching to the Kinesis stream. The second thing is, if in case somehow is not reachable, then you want to consider buffering to the local disk, because your client probably can't host that much data in memory. So you want to put it on the local disk somewhere on the machine that's generating the data. Now, if you're paranoid about losing the client-side disk, and this is critical data, you might want to consider making multiple copies on the client side. There are several Java frameworks that are out there. I'm not going to name any, but there's plenty enough that you can use to make multiple copies on the client side. And then the next option for you to consider is parallel ports. If for some reason Kinesis is down, it's not reachable, then Kinesis is now available in multiple regions. So you can either actually go to a different region in Kinesis, or alternatively, we have another service of our own. Prior to jumping on the Kinesis bandwagon, we built a software stack based on Flume and packaged up on EC2 and under auto-scaling groups attached to the ELB. It is now still on. It's always on. It's dormant. It can scale up on demand if in case we experience any failures. So use a strategy that makes sense. I'm sure there's plenty more that you can think of. A few bookkeeping considerations. The first thing is the UUID. I already touched on this one. If you are paranoid about data loss and you need to pinpoint exactly where it's happening, I'd recommend you to log a UUID, perhaps an MD5 of the payload, and a few other meta information that you can use later on during your audit. The other things to consider is a timestamp. If you send in a timestamp, our archive application takes the data out of Kinesis, writes it into S3, but using that timestamp, it very cleanly puts them into hourly buckets. So our MapReduce programs that kick in later on can actually process by the hour, and we also have a place to address the late arriving events, which can happen in some cases because of the complexity of the internet. And then this also, you can think about client-side encryption. Security and privacy is a big thing. And if there is, if there are things you're concerned about privacy, you can inject your own keys, encrypt your payloads when you're writing it into Kinesis and reading out of Kinesis. And then the record order is something that Ricardo is going to come back and talk more extensively about. So I'm going to skip over that one. And now let's talk about Kinesis managing client performance. So the very first time we tried Kinesis, we had issues. I'll be honest with you. So the performance, and because it didn't have batch APS at the time we were evaluating this product, we had some issues in terms of throughput. What that meant was we needed a lot more machines on the client side to handle the same kind of volume. So we got on the phone with Kinesis team and brainstormed ideas. And one of the ideas that came out of that discussion was to come up with this batch byte buffer concept. So we package multiple log lines into one byte buffer. We compress it and send it over to Kinesis. And it works like a charm. And that's how we've been able to do 1 million TPS a second. And Kinesis scales really well. And I have data to prove it. By the way, along the way, we also improved a lot of garbage collection because this is a lightweight. We developed a Flume Kinesis plugin that we simply drop it into the Flume that's running on our RTB engine, and that directly sends it to Kinesis without any other hops. So that's how we have addressed our client performance issues. Moving on, the aggregator. So we've talked about failure modes on the client side. Now let's touch upon the aggregator side. We look at this in 3 different ways. One is the availability durability, and the second one is the capacity. So let's look at each one of them. Kinesis, just like any other Amazon service, comes with availability and durability that you can trust. DynamoDB, for example, has got the availability and the durability, and so does Kinesis. So before they return the call back to the client, they make multiple copies in any given region. So you have multiple copies for durability as well as availability. And the system is designed to self-heal or do any repairs on its own, so you don't have to deal with these things. So this part is actually done for you. Second part is the capacity. So today in Kinesis, the unit of scalability is a shard. Each shard can handle about 1 megabyte per second or about 1,000 TPS. And on the consumer side, when you're reading data out of Kinesis stream, you can have up to 2 megabytes per second or 24-hour replay. So in order to shard, because we built a heavy automation around this thing. And the automation is because we don't know how much the clients are going to be doing. Sometimes the peak exceeds the previous peak in the next couple of hours, right? We don't know how much we're going to expect, how much volume we will be receiving. So we've come up with an automated solution to scale the shards. And here is how it works. Kinesis CloudWatch metric, there is something called putRecord.bytes. This simply tells you the bytes that you're writing into the shards. So if you take a sum of all the shards, you know the throughput that you're pumping through your Kinesis shards. Let's just do a simple math. If you have 2 shards, in theory, it can handle up to 2 megabytes. And putRecord.bytes will tell you how much it's actually processing. If you're close to a saturation, if you filled up your capacity, then you might want to consider expanding the shard. How do you expand the shard? Well, there is 2 operations called split and merge. Split is when you want to add capacity. You take one of the existing shards, split them into 2 at the midpoint, then you have 2 new shards replacing the previous one. So you just went from 2 to 3. That's what the picture shows. And then if you don't want that much capacity overnight, you can shrink it back down. You do the opposite, which is called merge. You take 2 and you combine it into 1. And you can do this all day long if you want with automation. But be careful, putRecords.byte is not the only one to drive your scalability. And here is why. So from time to time, you might receive throughput exceeded exceptions on the client side. That's normal. As long as it is a couple here, a couple there, that's fine. That's why you have retry mechanism. But if you are receiving throughput exceeded exceptions, and guess what, your shard capacity is full, that's a genuine reason to scale up, right? So you look at both of these together to make the decision. And we have scripts. We've deployed as CloudWatch alarms that can actually take these actions, and our developers can actually sleep at 3:30 in the morning. By the way, there are some tools in the GitHub. You can actually take a look at it if you are interested. Now, if there is one slide that you want to take home, it's this one. So the critical question that you always have to ask with the scaling, with large-scale systems, is will this scale? Will this scale as promised? So Kinesis documentation says 1 megabyte per second per shard. All right? So we took it upon ourselves to test it before we put it into production. So we started adding shards on this server side. We ramped up our clients on the client side. And we went all the way up to a million messages per second with 1,000 shards on the server side. Okay, the x-axis is the number of shards. As we were ramping up, the y-axis is the number of messages that we were pumping through the system. Conveniently, just to make the math easy, each payload was 1 kilobyte in size. Ladies and gentlemen, the red line is the picture-perfect or textbook linear scale, and yellow line is how Kinesis scales. And that's the proof is in the pudding. And get this, the kicker is actually in the total cost of ownership. So I did the back of the envelope math, and literally, and what I came up with was, for us, we're sending a million messages a second. It turns out to be we pack 50 messages into one. Why 50? Because 1 kilobyte message, you can have 50 of them. Kinesis allows 50 kilobytes per record call. So we pack 50 into one. And then if you apply compression to it, a 10-to-1 ratio, assuming 10-to-1 ratio, then the cost of this product, of this service, is $6,351. And if you didn't do any compression for whatever reason, or it's not compressible, guess what? You'd pay $28,000, which is a small price to pay for sending a million events per second. Step back and think about what million events per second does. It's 86 billion events a day. Now, the other good thing about async client is you don't have to provision for your peak. You provision for your average. If it was non-async client, then you have to actually provision for your peak capacity, right? Otherwise, you can't, you need to survive the system. The system has to work through your peak periods as well. But with the async clients, you don't have that. You can actually provision your average capacity. At average of 1 million requests per second, 86 billion messages a day, $28,000 is a small price to pay. All right, so let's see how Steve is doing. I guess he added more shards, and let's see how the shards look like now.
Right, so if you look at the first graph again, you can see how every 30 seconds we were able to add a new shard, because it looks like the steps. And in the graph on the right, you can see that going into the sharding process, we were about a little over 50 exceptions per second, and now we're down to 0. So by doubling the number of shards we had in our stream, we were able to completely remove all exceptions we were getting.
Thank you, Steve. So again, the proof is in the pudding, guys. He just scaled up the shards right in front of you, and the throughput executed exceptions went down to 0. And that's a live demo again. So let's look at the failure modes on the processing side. Dealing with bad records, there's two classes of errors, right, when you're processing. Processing is just as important as the client and the aggregator and everything else. Processing, two major classes of problems, bad records, or you have a problem with the availability of the processing nodes. Let's look at them. So bad records, dirty data. Guys who work in the ETL databases, data warehouse, nothing new to them. This is their life day in and day out. Now, what do you do is up to you. There are some use cases and workloads that you have to address yourself. And some of the things that you would do is you might skip a record. You might put it away in an exceptions table and come back to it later. Or you might bring your processing to a grinding halt. This use case is up to you, so you would have to figure that out. Now, bad worker. So when you're processing the data, your application that's actually draining the Kinesis stream might have issues. For example, if you're doing RTL, when I say RTL, it's like ETL, except in real time. And you're trying to do some dimension lookups. You have a key that's coming in, you want to substitute with a name, and you want to do a database lookup, and database is not available. Well, you have a couple of options. You can retry, or you can shut the processor down. The meta point is this, folks. If you are having issues, don't checkpoint. Because checkpoint is actually an offset into the stream. Once you checkpoint the code, that application checkpoints the stream, Kinesis is going to assume that this application is done processing that data, and it won't give it to you anymore. So the meta point is, don't checkpoint if you haven't finished processing. If you have finished processing, go ahead and checkpoint. All right, let's look at the processing side, a little bit of an animation to see how it works. And then again, we'll go back to the live demo and see how it works in reality. So this big yellow box in the left-hand side is Kinesis stream. And there's an invisible producer writing to this big block of stream. And on the middle, you have Amazon Kinesis consumer fleet. So consumers are draining the data from Kinesis. And this application, we call it Archiver, is reading data from Kinesis stream and writing into S3. So we want this to be highly available. Because if we fall behind, what happens is our producers are blasting data at lightning speed. We're going to fall behind. So we have to make sure that this KCL, or this application, is highly available. We built this on top of KCL, Kinesis Client Library. It comes with Kinesis Standard. And the good things that it does for you is checkpointing. So let's see how this works in animation. So here is the producer writing data. And that's the KCL worker reading data. And then more data coming in. And then KCL application reads that data. And now it does a checkpoint. So basically telling the stream that, hey, I'm done processing this data. And then it took that data and put it up in S3. That's what our archiver does. It takes the data, copies it from Kinesis into S3. And then the checkpoint record appeared right under there, which is that's the DynamoDB table on the bottom right-hand side of the screen. And it added a row there. KCL does this for you. You don't have to do it. That's what the checkpointing does. It makes an entry there. And now more data comes in. KCL read it. We are at item number 18. More data coming in. It's still reading it. Guess what? We failed. The host failed. Whatever happened, the KCL worker node or archive application that was processing the data, taking it from Kinesis and copying it in S3, just failed. So let's see what happens. But remember, the last checkpoint was done at 10. So we have no fear. The data hasn't gone anywhere. So what happens then is the new KCL pops in place by auto-scaling group. It looks at the previous checkpoint, which is 10, takes ownership of the data, starts reading everything after 10. So let's actually look at this in real live demo. Steve?
So for this demo, we'll focus on this last row here. So we want to highlight the load balancing fault tolerance that comes out of the box when you use the KCL. So what we did was I went in and killed the process running on Archiver 1, so it's not processing anything now. And you can see that Archiver 2 is beginning to start picking up some of its load. So it won't happen immediately because we've configured our applications to take about 5 minutes to fail over to find new leases that have been orphaned. But it'll start picking up the events and take over the load of the previous archiver as the load gets balanced over to the second one.
So there you go. You have a second archiver picking up the load from the previous checkpoint and moving on. Thank you, Steve. So let's go through the rest of the failure modes in storage. Ricard already mentioned that KCL keeps data in the stream for about 24 hours. And if you don't want to lose your data, so what Kinesis allows you to do is small window analytics. What do I mean by that? You can look into the stream and say, what's happening every 5th minute of the hour? Or you can look at what happens at the top of the hour, every hour for the last 24 hours. And the best part is you can also take the data and combine with the rest of your larger analysis by putting it into S3. You can run your favorite Hive query or any MapReduce application and make that data available as part of a much larger analysis. So the reason why we use Archiver is if we are directly processing it from the stream, and if we have a release regression, every once in a while you have that, right, in the engineering organization, what you want is your brain-dead application that does not change or rarely changes. It knows how to copy data from point A to point B. So we don't have release regressions or anything with that. It's like a cast-in-stone kind of an application. So that's what we do for our to preserve the data, because this is mission-critical data, that we also need this as part of a much larger analysis. And then I just want to let you know that the data, so we've been at this about 1.5 to 2 years. We are building this marketing cloud. And this is how it looks today. We use a Qbol for the ad hoc analysis and MapReduce for all our production workloads. Kinesis is our main real-time ingestion. we have a lot more to go. Like I said, we are building this marketing cloud. We just got started. We have very ambitious plans of building our marketing cloud. And guess what? I'm going to shamelessly advertise that we are looking for top talent. And if you want to join the awesome engineering team at DataZoo, please come see us. We are hiring. And let me invite Ricardo back up. He's got a few scenarios, the order processing and the EMR to cover. Thank you.
Yeah. I know I just have a couple minutes here, but we are going to be available for questions. I want to talk about some more failure modes here. Basically, some of the next steps that DataZoo is actually going to take as we start looking into potential issues that you could have with record order and record replay. So we talked about scaling to multiple shards. As you know, the actual record sequence is maintained at a shard level. Right? So if ordered processing of the records is important, this is something that you need to take into consideration. And it all starts with the record. So the sequence number, the partition key that you choose before you do your put record dictates which shard that record is going to end up in and which worker is going to process. So if you have unordered processing records, and there's plenty of use cases that the order of the records don't really matter. It's how many of them you have, for example, in a given time frame. You can randomize your partition key and make use of as many shards, 1,000 shards, like in case I mentioned, and as many workers as you want, not a problem. If exact order processing is an issue, is a requirement, for example, if you're doing fraud analysis, or if you want to have a targeted ad that shows up at a specific behavior, then you need to control that partition key. That's the mitigation here. Be aware of the partition key and its implication on how it controls where the record will get placed. If you need both, consider getting a global sequence number outside of Kinesis. You can use, for example, an atomic counter in DynamoDB, get that sequence number, put it as part of the record payload, and then use that in downstream to kind of put the sequence back together. Okay? Now, as you all know, if you've been following our blog, we have a new enhancement, a new feature that's been released for DynamoDB, which is the streams. And it kind of impacts this pattern here. And this is something that we're going to be blogging more about in our big data blog. So if you're interested in this pattern, the details on this pattern, and how it relates with the new feature now available with DynamoDB, definitely check out our big data blog in AWS. We'll be talking about those. Another thing that you see here as well is not every destination of the record is the same for every producer. Depending on what event type you're sending, it may make sense to use a certain type of partition key. So it's a good idea to have a very low latency service that tells you what that is, and DynamoDB is good for that. A quick lookup to figure out, hey, I'm a certain type of event. To where should I put this record, and what type of partition key should I use? This is, again, a very good pattern that allows you, it keeps the latency, meets the latency requirements, but gives you that flexibility to dictate where the records go. Another pattern that we want to talk about here that allows essentially an infinite replay of those records is this EMR-based approach. So you all are probably very familiar with reading lots of records in a very fast distributed way from S3. So the approach that we take here in this pattern is to pick up the records that have been archived there and play them back into the original streams. Now, the way that you do this is that your EMR jobs tag the record payload with an event ID so that downstream applications that don't care about the past, it can ignore that record. And if you do that right at the header, right in the front of the record payload, you can save time. You don't have to unpack the record, deserialize it, and do all those things. This is a very nice pattern because it allows you that at any point in time, you can play back records from last week, last year, whatever. And again, this is something that we're going to be providing more details in our blog. So what have we mitigated for today? It's just the beginning. Like Kinesis said, you probably could have thought of other scenarios. I'd love to hear about them in our Q&A session later on. But we talked about, first of all, relying on our SDK. Right, the fact that we have async clients, the fact that we have some pretty good robustness already at the client level that you can mitigate for the issues that we described there. Aggregator mitigation is the easiest. Use Kinesis. That's it. Kinesis and KCL. That's the easiest step on the slide here. The processing layer, go back to what Yukesa mentioned. Ask yourself, what sort of record loss ratio can you withstand, right? Is it okay to just keep processing? Or do you have to stop and put the records aside and go back and analyze it? So there's, again, it's a business decision that you need to make, and KCL can support that. From a storage perspective, an S3 archiver should be part of every mission-critical Kinesis application fleet. And this EMR-based infinite replay pattern is, again, something that you can use very efficiently. So with that, thank you for coming to the session. We'll be available over there for some Q&A. And please give us feedback. Thank you so much.